Hi everyone, we are on our last regression question for this section, and it is regarding coordinate points. So just like the tables were helpful to calculate regression models, you can always use just 2 points. However many points they give you is enough as long as you have more than one. So the per capita or per person cigarette consumption in the US dropped from 3,000 in 1980 to 1,634 in 1999. Create an exponential equation for the per capita cigarette consumption, C of T, where it's been T years since 1980. So we know that we're starting in 1980, and 1980 equals T equals 0. And let's just enter this data. So our time is like X, our input, and C of T is like Y, or our output. And we know that there were 3,000 in time 0, 3,000 cigarettes per person, that's a lot of cigarettes, to 1,634 in 1999. So that would be 19 years later. And so that's all the data we need. Interpret the meaning of the numbers in your model using everyday language. So we need an exponential regression equation. Let's go ahead and clear all our data out. Let's go to Stat, Edit, and clear our lists out. And now we just enter those 2 pieces of data. 0, enter, 19, enter, that's our first column, and then 3,000 and 1,634, enter. And then we go to Stat, Calc, go down to Exponential Regression, enter, 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 and there is the equation. A equals 3,000, B equals 0.9685279255. And so we can use this calculated exponential regression equation to model our data and to interpret the meaning of the numbers. So what I'm going to do is go to Y equals, clear out what's in there, clear out everything that's in there if there's more than one equation, and then go to vars, go down to Stat, enter, arrow to the right to equation, enter. There's our equation. Now go to graph. Now this might be really weird because our initial data was very small data from our previous problem. So let's go to zoom and then 9, which is a zoom stat. And see, now we see both data points, the one up here and the one down here. This looks like exponential decay, and it looks like people are not smoking as many cigarettes as they used to. Let's zoom out just a little bit more. Just to see what the trend looks like. That looks very good. That looks like a very accurate representation of this data. So if we interpret the meaning of the numbers in the model using everyday language, I'm going to go back over to the equation really quick. We have Y equals 3,000 times 0.9685, and I'm just going to round it to 4 decimals. Raised to the x. What this is saying is that the per capita cigarette usage is decreasing. And now let's just figure out by how much. So we have 1 would be no change. It would just be the same amount every year. And then let's subtract 0.9685. So it's decreasing by 3.15% a year. I hope you find these helpful.